1. Blue giants. Blue giant stars are among the hottest and brightest stars ever observed. Their surface temperatures can exceed 30,000 degrees Celsius, causing them to radiate enormous amounts of blue and ultraviolet light into surrounding space. Compared to stars like our Sun, blue giants consume their fuel at extreme speeds. A star similar to the Sun may survive for billions of years. Some blue giants exhaust themselves in only a few million. The pressure inside these stars becomes immense. Their cores fuse heavier and heavier elements, while radiation violently pushes outward against gravity. From a distance, blue giants can dominate entire regions of space with their luminosity alone. Some are hundreds of thousands of times brighter than the Sun. Despite their beauty, these stars are unstable. Many eventually collapse into neutron stars or black holes after catastrophic supernova explosions. For a brief period, the explosion of a dying blue giant can outshine an entire galaxy. 2. Red supergiants. Red supergiants are some of the largest stars in the known universe. These stars form after massive stars begin exhausting the hydrogen fuel inside their cores. As fusion slows and changes internally, the outer atmosphere expands outward to enormous sizes. If one replaced our Sun, its outer layers could extend beyond the orbit of Mars. The surface of a red supergiant appears relatively cool compared to smaller stars. That lower temperature gives the star its deep orange or red coloration. Despite their cooler appearance, these stars contain extraordinary amounts of energy. Their atmospheres are unstable and constantly shedding material into space. Some lose mass so aggressively that they create gigantic clouds of gas surrounding the star itself. Astronomers believe many red supergiants eventually die in supernova explosions powerful enough to briefly rival the brightness of entire galaxies. Some of the heavier elements found on Earth today were likely created during explosions like these billions of years ago. 3. White dwarfs. White dwarfs are the dense remains left behind after smaller stars reach the end of their lives. After exhausting their nuclear fuel, stars similar to the Sun collapse inward dramatically. The outer layers drift away into space while the remaining core compresses into an object roughly the size of Earth. Despite that relatively small size, a white dwarf may still contain most of the Sun's original mass. Gravity inside becomes so intense that normal atomic structure begins to change. Matter enters a strange state known as electron degeneracy pressure, where quantum mechanics itself helps prevent further collapse. These stars no longer generate energy through fusion. Instead, they slowly release leftover heat over billions of years while gradually cooling into darkness. Some white dwarfs remain incredibly hot long after the original star has died. Their surfaces can glow with pale white or blue light while the dead stellar core quietly drifts through space for ages longer than human civilization has existed. 4. Carbon stars. Carbon stars are among the most visually unusual stars ever discovered. Their atmospheres contain abnormally high amounts of carbon produced deep within the star itself. As the star ages, internal convection pulls that carbon upward toward the surface. The carbon absorbs shorter wavelengths of light, causing the star to appear deep red, orange, or even blood-colored. Some carbon stars become so saturated with carbon that soot-like compounds begin forming around them in space. Astronomers believe these stars may contribute enormous amounts of carbon to the universe over time. The carbon released by dying stars eventually becomes incorporated into planets, atmospheres, and living organisms. In a very literal sense, some of the carbon inside the human body may have originated inside ancient stars like these. Certain carbon stars also pulsate dramatically, expanding and shrinking over long periods while ejecting material outward into surrounding space. Against the darkness of space, many appear less like ordinary stars and more like glowing embers drifting through the galaxy. 5. Neutron stars. Neutron stars form after massive stars collapse under their own gravity during supernova explosions. The collapse becomes so violent that electrons and protons merge together into neutrons. What remains is one of the densest objects in the universe. A neutron star may contain more mass than the Sun compressed into a sphere only 20 to 25 kilometers across, roughly the size of a city. The density becomes almost impossible to visualize properly. A single teaspoon of neutron star material would weigh billions of tons on Earth. Gravity near the surface becomes extreme enough to noticeably bend surrounding light. The crust itself is believed to contain some of the strongest material known in the universe. Even tiny disturbances inside the star can release enormous bursts of energy into space. Despite their small size, neutron stars are the collapsed remains of once massive stars that violently destroy themselves. What survives afterward is something far stranger than the original star ever was. 6. Pulsars. Some neutron stars rotate at extraordinary speeds while emitting focused beams of radiation from their magnetic poles. These objects are known as pulsars. As the beams sweep through space, they appear to pulse rhythmically when viewed from Earth. Certain pulsars rotate hundreds of times every second with astonishing precision. The timing of those pulses became so accurate that early researchers briefly considered whether the signals might have been artificial in origin. The first discovered pulsar was even nicknamed Little Green Man 1 before its true nature became understood. The rotation of a pulsar stores enormous amounts of energy. Over time, the object gradually slows as it radiates that energy outward into space. Some pulsars emit radio waves. Others emit X-rays or gamma radiation. Around certain pulsars, astronomers have even discovered planets surviving in orbit around the dead remains of exploded stars. These systems are among the strangest planetary environments ever observed. 7. Magnetars. Magnetars are neutron stars possessing the most powerful magnetic fields ever detected. Their magnetic fields are so intense that they can distort atomic structures from enormous distances away. At close range, a magnetar could potentially disrupt molecules themselves. Even from thousands of kilometers away, the effects would likely be catastrophic for electronics and communication systems. The surface of a magnetar is constantly under enormous stress. As the crust shifts and fractures, violent star quakes release gigantic bursts of radiation into space. Some of those bursts have been detected across vast distances within our galaxy. In 2004, a magnetar eruption briefly affected Earth's upper atmosphere despite occurring tens of thousands of light years away. Among known stellar objects, magnetars are considered some of the most dangerous and extreme. They represent matter compressed, magnetized, and stressed to levels difficult to fully comprehend. 8. Wolf-Rayet stars. Wolf-Rayet stars are massive stars undergoing extreme mass loss. These stars generate violent stellar winds powerful enough to strip away their own outer layers over time. Material erupts outward at millions of kilometers per hour, creating enormous expanding clouds around the star. The exposed interior beneath becomes extraordinarily hot and luminous. The hottest known Wolf-Rayet stars can exceed 200,000 Kelvin. Their surfaces often appear chaotic and unstable as radiation and stellar winds continuously reshape the surrounding environment. Astronomers believe these stars may eventually produce some of the most violent explosions in the universe. Certain Wolf-Rayet stars are considered possible gamma-ray burst candidates. If one of those bursts were directed toward Earth from close enough range, the consequences could be severe for life on the planet. Fortunately, no known Wolf-Rayet stars currently pose an immediate threat to Earth. Even so, these stars remain among the most violent stellar objects ever observed. 9. Thorne-Zytkow objects. Thorne-Zytkow objects are among the strangest theoretical stars ever proposed in astrophysics. According to current models, these objects may form when a neutron star collides with and sinks into the core of a red supergiant. From the outside, the resulting star could appear relatively normal. Deep inside, however, an ultra-dense neutron star would exist at the center. That hidden interior could dramatically alter the chemical behavior of the surrounding star. Astronomers have searched for unusual elemental signatures that might reveal the presence of these objects. Only a few possible candidates have ever been identified. Even today, scientists still debate whether Thorne-Zytkow objects truly exist in nature. If they do, they represent one of the strangest forms a star can take. A dead collapsed stellar core hidden inside another living star.